This is our LED persistence of vision display. We have here under this paper our 48 red, green, blue LEDs. The paper is over them to diffuse the color and make a better image. You can see our printed circuit boards here. There's two of them lined up next to each other. And these are what hold our LED drivers and LEDs themselves. They are connected to our microcontroller by these ribbon cables into these boards to our controller inside this black box. Right here next to it you can see our Bluetooth module, which connects to our computer so we can send images wirelessly. On this end of our rotating arm we have our DC to DC converter. It converts 12 volts DC to 5 volts DC. Our controller uses 12 volts and everything else, the LED drivers and LEDs themselves, use 5 volts. And this is merely our method of communicating with the microcontroller. As you can see, the arm spins very freely. This needs to be the case because this needs to spin as fast as we can get it. As it spins, it passes over this fiberglass tube. Inside this tube is an infrared LED which emits a beam narrowed by this tube. And on the underside of our arm is an infrared receiver sensor. And as it passes over the LED, it triggers an interrupt in the firmware which starts our new rotation algorithm. Down underneath in the base you can see we have a 300 watt computer power supply which can supply about 20 amps to our motor. And on the bottom you can see our pulley and belt drive system connected to our motor. As the motor turns, it turns the entire mechanism. We just have a 1-to-1 ratio right now, but we could increase that to get higher speeds. At the bottom of our shaft, wrapped in white tape, is our rotating electrical connector. This transfers power over to a spinning shaft. This particular one is rated up to about 3,000 RPM. And connected off to the side, we have a little control box and a switch over here we can use to turn the motor on or off remotely. So we don't have to get up too close to the thing to turn it on and off. We transfer images to the display using a Bluetooth communication. We have an algorithm built into MATLAB with a GUI that allows us to do this, and we'd like to show that to you now. Here is our program we use to send images wirelessly to our display. We load an image by clicking this button here, and as soon as we find where our images are stored, documents. There we go. You merely upload an image and it appears in this little window here. You select which part you want to show, and then this window here shows what will show up on the display. Then we format it, meaning we break it apart into its red, green, blue values. And what this is doing is going pixel by pixel and taking the red, green, and blue value of each one. We store these separately into different bytes so we can send these to the controller. This allows us to display any image in any color with our red, green, blue LEDs. And then below is where we connect to the Bluetooth module, start, stop, and send to the display.